For this lesson, we're going to be solving absolute value inequalities. So we solve absolute value inequalities just like we solve absolute value equations, but our solutions for absolute value inequalities are represented by shading and closed circles. So if we have an open circle, that means that it is not equal to that number where the point the open circle is, and that's when we use these types of inequalities. When our circle is closed, then that means it's equal to the point, so it represents that point. That point is a solution, and we use these symbols to represent that, the ones that have that equal sign under it. So we're first going to graph x is greater than 2. So on a number line, if we put 2, we have an open circle because there's no equal sign under it. And we say x is greater than 2, all the points that are greater than 2 are on the right side of 2. So this is how we represent x is greater than 2. And if we have x is less than or equal to on a number line, we have 10. There's an equal sign, so that means we're including that point. 10 is part of our solution. And x is less than are all the numbers on the left side. And these are all the numbers that are greater. And this one is equal. So if we were to get a solution where all my x's are greater than 2 and where x is less than or equal to 10, then on our number line, we can get 2 and put 10. 2 is open, 10 is closed, and we're going to graph it in the same direction that we had these. So to the left of 10 and to the right of 2. So my solution set is everything in the shaded region and anything that is on that solid point or the closed point. So the way we write this inequality is we say x is anything greater than 2 but less than or equal to 10. And this is my inequality notation. Okay, let's look at another example. Let's say we have x is less than or equal to 3. On our number line, we've got 3. There's a line under it, so we have a solid point, which means it's equal. And x is less than is anything on the left side of that 3. Let's say we have x is greater than or equal to 6. So we've got 6. It's also closed. And all the numbers that are, that it's equal, greater than 6 are on the right side. So if we were to put these together, we would have 3 on the left, and then 6 closed to the right. So this can no longer be and, because a number cannot be less than 3 and greater than 6. So in this case, we say x is less than or equal to 3, or x is greater than or equal to 6. All right, so when we solve inequalities, we have less or equal to. These are less than. What I mean by that, all right, so when we solve inequalities, we're either going to have solutions that look like this, or where they go towards each other, or where our solutions are away from each other. And this type of solution set is called a conjunction. This type of solution set is called a disjunction. Okay, let's solve our first inequality. We've got the absolute value of 2x plus 1 less than 5. So again, we first want to isolate my absolute value. This one's already isolated. So when we separate it into the positive and negative of that 5, we do 2x plus 1. And then we're going to copy the inequality exactly as my original. My negative sign, on the other hand, we've got 2x plus 1 we're going to switch the symbol and we're going to make the number negative, just like we did when we solved for the equation. And then after this, we solve for this side. And then after we get our two solutions, then we're going to put it on a graph. My -3 would be on this side of the number line, and the 2 would go on this side. Both of them are open because neither of them are equal to. And in this case, we have x is less than 2, so we're shading in this direction. X is greater than -3, so we're shading to the right. So my solution set looks like this. And our inequality is our x's are greater than -3, but less than 2. This is my inequality. So it's basically all numbers between -3 and 2, not including -3 or 2. Okay, let's look at the next example. We've got the absolute value of 3x plus 5 minus 3 greater than or equal to 1. So again, we want to isolate this absolute value. And now that our absolute value is isolated, now we can break it up into our positive and negative. So for our positive, we're going to use the exact same inequality. And for our negative, we're going to switch it up. So we're going to switch our inequality and we're going to make it negative. So let's go ahead and solve. We're going to subtract 5, 3x greater than or equal to -1, divided by 3. X is, greater than or equal to -1 over 3. Over here we have -5, -9 divided by 3, and x is less than or equal to -3. So let's go ahead and graph it on our number line. -3 is on the left, -1/3 is on the right because -1/3 is bigger than -3. So we'll put our circles. Because they're both equal, then we're including these points as our solution set. And x is greater than -1/3. That means greater is on the right of -1/3. Over here, x is less than or equal to -3. Less is to the left of -3. So in this case, we have a disjunction. So all our x's are less than or equal to -3, or our x's are greater than or equal to -1/3.